Hello, everyone. Welcome to our reality capture education series. In today's session, we will be exploring the unexpected way to dominate in topographic data extraction. I'm Christine Grail with Leica Geosystems, part of Hexagon, and I'll be the moderator for today's session. Our instructor today is Kyle Palmer. Kyle is a registered professional land surveyor in the state of Texas, and he began his career as an instrument operator and worked his way through as a surveyor. Kyle, tell us a little bit about your background.
I started in a smaller, to medium-sized firm in East Texas, and I started out cutting brush and staking out pipelines. And I touched a lot of things in my career, and a lot of times we had to shoot roadways. And I remember one thing, thinking as a surveyor, am I getting everything? Am I covering everything? And am I capturing it all accurately? And then in some of these areas, it's kind of unsafe, like crossing a roadway. Um, and I remember thinking, not to be too much like a TV commercial, but there's got to be a better way. And when I discovered LiDAR technology, I knew that, I had found that answer.
So you worked with LiDAR for about 15 years before you came to Leica, correct?
Not quite. About 2012 is when I started working with LiDAR data. So what is that? Gosh, it's like, is that 14 years? I'm not
Do
doing the
some quick
math.
math on the spot.
Yeah. Yeah, but about 10 or so years, yeah, maybe 14 years now. Gosh, it's been a
Okay.
long time. But I've started
Yeah.
working with the C10, and I fell in love with capturing LiDAR data and processing. It's a fun niche in surveying and geomatics.
Yeah, for sure. And now, of course, you are the mobile mapping consultant, one of our mobile mapping consultants here at Leica Geosystems. Tell us a little bit about what you're doing these days.
It's really exciting what I'm doing. I get the opportunity to represent the Pegasus TRK for Leica, and you know, for a while, a lot of these systems, the trend curve is towards simplification, and I think the Pegasus TRK's really got it with mobile mapping. In the past, it was just this complicated thing that you had to have a geodesy degree for, and you kind of had to run it every day to stay in practice, and there were all these measurements you have to take. Now, you just put the system on the top of the vehicle, and you can collect whatever you want. It's so fast, and honestly, it gives you more time to look into your data extraction workflows. I mean, before it was like a lot of time for setup and breakdown and making sure the data looks right. Now it's just like you're already in your LAS format or E57 format or extracting features before you know it. It's just the time curve is just so fast. It's ramped up so fast with the TRK. It's a great system.
Yeah, we've heard a lot of great things about it. So obviously you're very excited and you spend a lot of time on workflows. You're working on how to make things faster, how to help professionals do things faster, more efficiently, how to do some things creatively, and that's part of what you'll be showing us today. I do want to let those of you in the audience know today's session is live and interactive, so please do ask questions and make comments as we go through the material. If you need Kyle to slow down or show something again, just pop that request into the questions box that you should see on your screen. We will address these comments and questions with Kyle during the session as time permits. Also on the line with us today is Leica reality capture specialist, Jonathan Efall, who will be responding to your comments and questions behind the scenes. And I did want to let everyone know, just to set expectations from the outset here, that this is not a training session. It's not an in-depth coding course. What we really just want to do is give you some ideas for things that you can do in your business that you might not have realized or that you might have thought were much more complicated than what they actually are. And then we'll give you some resources that you can take and dive into that more on your own time. And of course, certainly the people that we have here are more than happy to answer any questions you might have. Now, before we get started, we do have a quick poll that we'd like to share just to get a sense of where everyone is in the reality capture journey. And you should see that quick poll on your screen. That is, what is your biggest pain point with laser scanning? Go ahead and answer that. And we'll give everyone just a few seconds just to see where we are here. It looks like, everyone's paying attention to the title of the webinar today because we've got a lot that are saying extraction is really painful. So I'm going to go ahead and close this out and show the results. We did have some with registration, but it looks like that extraction is really where everyone's at. And
good.
So with that, I am going to go ahead and to turn it over to you, Kyle. So once you see that on your screen, you can go ahead and
All
accept
right.
that and we'll get rolling.
All right, let's share. I'll share my
Okay.
screen with you. I'll do a brief. Everybody can see that?
Yes, go ahead into presenter mode. Perfect.
Okay,
We got it.
perfect. Good. Thanks for your patience, everyone, on that. I'm going to show a brief PowerPoint slide, and there'll be a handout for this, so no need to write everything down. But I just want to talk about why you would want to do this, and then some pointers to do it, and then we'll go into a live demo that will demonstrate that. And yeah, one of the things I didn't mention in the brief interview from the top is I kind of get as being in this role is a great bird's eye view of what everyone's working on, what kind of workflows they need. And so I get to see all these different workflows from all over the country. People asking me different questions. How do I do this? How do I extract that? And how do I extract this and that? And one thing I realized is it gave me a global perspective in that, no one software from any company is going to have every single tool you need. And so your workflows are unique, and there's something about them, even if it seems like a typical like gas station topo. There's a difference between a Wawa in Pennsylvania, and a QT in Dallas, right? There's just subtle differences. And so you need to move quick. Your customers, everybody expects everything quick. We have Amazon 2-day shipping, and that's just how life is. And it's the same with your data processing. So why wait on an official release to have the tools that you want? So you can build these tools and tailored to your projects. You can save button clicks on common workflows, and it allows you to be fast, flexible, and very efficient. And each one of these scripts serves as a documentation of a workflow. So you have a similar workflow or something that is cousin to another workflow, just a similar task that you might have to do. Maybe, like I said, that gas station topo. You pull some pointers and some tips from what you learned on that project, and you apply it to like a topo for a treatment, a wastewater treatment plant or something like that. So, and then from a management perspective, if we have any managers on the phone, you say, well, why would I put some time into this? This is I'm pulling a productive employee into kind of some R&D. Well, if you're hiring recent graduates, I can tell you most everybody studied GIS. They've studied some kind of GIS, or they've touched programming in some way. So you've got these skills that are sitting on staff that you can use to make you more efficient. And I'm going to argue that, from a surveying perspective, as a surveyor, surveying and engineering companies they're tech companies now. I mean, you're going to these conferences like GeoWeek and seeing all the new gadgets and everything like that, and you're taking on and evaluating tech, and your workflows and your work product is only as good as the equipment that you use. That's just one of the pillars of good work. So, and then your workflows too. And I'd say R&D is a rock solid investment. Just for all the managers here who've been in this for a long time, just think when you set up your first field to finish feature code list. Think about how much that changed everything. You weren't having to manually change codes and all that stuff. You just put it in to whatever CAD software you were using, and it put a symbol on everything. And it made all the lines the right color and right scale. It's the same thing except for laser scanning workflows. So I made this meme. I hope everyone enjoys that. Put a little time into it. But it just says, your analysis is an asset. It's what you use to be successful. Your custom analysis. As a surveyor, we're paid to analyze and produce an analysis. And so those workflows that we have are our tools now. They're our machetes. and total stations, just as valuable as those. So is scripting right for me? That is one thing you got to ask yourself before you launch into this and spend a lot of time building a tool. If it already exists in the software and it's just one button click, or and then entering a few things, yeah, probably not. We don't want to spend time rewriting something that exists. You just don't want to waste any time. Just use the thing that's there. Be efficient with your time. You have so little of it. But if it sort of gets to where it's like it's not quite right for what you need and you have to keep customizing it in some way, or doing a multi-step process, combining multiple tools, and it's a workflow that happens a lot that you think you're going to use again and again, then that's definitely a time to investigate this. One-off workflows, maybe not. Maybe just do it the one time, write it down for the future, take some notes on what you did. And then also it helps you hand off a project. Like I said, this is a document, a workflow document that explains exactly what it did. And you can make notes in here that are easy to read if you don't understand JavaScript. But the tool that I'm going to show today is Cyclone 3DR. And it's our toolbox. It's our toolbox for all things LiDAR. You don't know what you're going to get into. You don't even know where you're going to start. You just kind of throw it all in there and you start analyzing. You string together a set of tools. It's amazing. Like, it's sensor agnostic. Wherever you get the data from. If you get drone data from drone interpolated ortho imagery to a point cloud, and you need to combine it with your laser scanning data, I mean, this has got it all. And it has a great help guide. So if you work through the beginner's help guide, you'll be able to use the software in a day. It has a really powerful script API. It's really easy to write scripts in here. They give you a lot of examples too, and a lot of signposts. So we're going to go into our live demo here. I'm going to pause for a moment. We're going to go into our live demo, and I'll show you. All right. Everybody see this okay?
Yes.
So this is a training mission that I went and did with a customer in Omaha, Nebraska. This is for a Pegasus. This is Pegasus TRK data, and I imported it in our LGS format. And so one of the fantastic things is this took us like an hour. I mean, we did this whole bridge, just amazing results, like really, really just quite a bit of freeway that we just said, and it wasn't like the old days of like, oh, we got to study this whole thing and the directions of the roads and all that. It was like, we need to go run something for a training mission. What are we going to do? Oh, there's a bridge out there. Let's just go run it. And the results are incredible. This is high traffic. This is during the lunch hour, tons of traffic on the road, and the data lines up perfectly. Everything looks really clean. And what you're looking at is the classified data. And let me tell you, I've been looking at a lot of classification models in my career. I've seen a lot of different ones, and this one is top notch. And I'll show you why. The curbing. If you ever just wanted to extract your curbs, if you ever you scanned a roadway and you just need the curbs out, the Pegasus algorithm for extracting curbs and roadways is beautiful. It's perfect. Also does a great job handling traffic, the natural ground, different classes of vegetation. This is with the NEO sensor, so it's got 4 returns, and you've got a great, vegetation penetration. This time of flight LiDAR, it just looks really good. So does this great job of classification. So we collected the data, super easy, right? We went out and just ran this, and just on a whim. And then we ran it through the software. It took us a couple hours, just a little QC, wait for everything to load and export. And then we classified it, and it did a lot of the work for us, because back in the day you used to have to separate this road out manually. That was the old days, and then you used to hope your ground classification was any good. Not with this program, but not with Pegasus Office. So we've got a lot of the work done, but still, let's look at the real color. Still, we need to pull things out. They need to turn into lines. And as great as meshes are, as great as point cloud as a deliverable is, and we've all probably had that conversation. You know what? Your customers want lines. They want lines in a drawing. So how do we get those out? Well, we have some options. When we all know you can click, click, click along here, draw a line. You know, um, we can try to pick lines out of there, and we'll be pulling our hair out, right? That's not great. You don't want that, because this is a lot of roadway to topo, and people are on the phone asking for results. So we got to get smart. And here's where, like I said, that recent geomatics program grad is going to come in handy, because they probably took a GIS course, and merging the some GIS principles with surveying principles, this highly accurate LiDAR, you can use it to really speed up your workflow. So in the old days, like I said, we used to think of, a point was a point, and this was all a survey point, and you just had to classify it yourself. But you can use each one of these points is full of additional tabular data, and some of that's real color, some of that's inspection, and you can use the relationship between the points to separate it. So what I'm going to do is actually, we'll go back to classification. I'm going to click here, and I'm going to go to clean, and then I'll do something called explode by class. And this is really interesting. What it'll do is all these different classes, it'll explode them in the software by layer. So so we can see it's segmented them all. So I'm going to highlight only the road surface, and we'll take a look at that. And still a little noisy, that's okay, but it pulled out all the road. What you actually want with something like this is you don't want it to be too aggressive. You don't want it biting into your road. So I'd rather, when I classify or clean up noise in an automated way, I would rather leave some and then manually clean it out, because I like certainty. So I'm going to go ahead and copy this for the demonstration purposes. Okay, and I'm going to copy the road surface. Paste. Okay, all right, so we'll show only. Okay, so I'm going to use an automatic noise filter. We're going to clean this up a little bit. Noise filter is pretty good on this, and what it'll do is it'll highlight. It's a really interesting tool. Anytime you change, you finalize things. So what it'll do is it'll go through and it'll look for all the noise, and then it'll give you a chance to review it, and then you can go, oh no, it was too aggressive. For reasons of the webinar, I'm just going to go ahead and accept the results and hit OK. I'm not going to look at this too closely, but you can see the results here. So hit OK. Now, now we have a lot of the noise cleaned up. Now we can go look at how do we pull out the paint stripes. So one option in here is, now that I'm just looking at the road surface, is I can go through here, and there's a way to segment using that additional data, not just X, Y, and Z, but intensity and real color. The real color tool is really interesting, but you can go through here and pick, you can pick real colors, but it just so happens that this paint's pretty faded. This is in Nebraska, and it's a bridgeway, and it gets salted and sanded and plowed all the time. So the paint stripes are, kind of degraded. And so in a lot of places, it looks very similar to the asphalt, because the asphalt is also faded and sun-baked. So real color is not maybe the best way to go in this. I did test that for this, and that's why I came up with this workflow. But if you had fresh black asphalt, white paint, and yellow stripes, you can pull out multiple different colors and stack them all together, regroup them. It's a very interesting tool. Let's cancel. But what I did find out that works is we can mess with the inspections, and there's a really interesting color ramp in here called over under. And what it does is it segments it just and it segments in half the point cloud and picks a natural breakpoint. It automatically calculates it for you. In this case, the intensity value. 4.991. And somehow, almost like magic, it kind of knows that's the right number. If we look, we can see this clear definition of the paint stripes, because those are more reflective points, because they have reflective paint. Okay. So again, there's this. So now I've segmented. Now I've redone the inspection. And there's this tool in here called, segment by scalar steps. And what that'll do is it'll split it in those two inspection layers. So now we have this, again, really interesting result. Look at that. So now I can turn off all those points that they don't fall with that in that correct intensity range. And now what does that look like? That looks pretty much like a point cloud of all of my paint stripes with some noise. Now, typically, you can go through and you can denoise, you can use automated tools, but then again, you run into the hazard of what I was saying. Sometimes you can run automatic filters to a point where, and you've probably seen it in your registrations, you hit the optimize too many times, or you try to use an automated tool and it just produces a result that you're not crazy about. And it's time to get out, it's time to do a little bit of elbow grease. And that's what I did here. And I've got that kind of canned up. So what would happen is, and I'll actually illustrate that, is if I ran a noise filter, what it would do is probably eliminate too many points. Like for example, here, I know that's a valid paint stripe, and it's just based on the way the noise algorithm works. It's eating up stuff that I actually want to keep. So I manually cleaned this, and it took me about 20 minutes on this size project. And so we're going to go to that again. That's canned. So we're going to take a peek at this. Right. So this is completely cleaned up. And the more clean you get it, the better this tool will work that I'm going to illustrate, and I'll show you in a minute. So then what I would do is I'm going to go back to this cloud and do the rest of the workflow, and then we'll go over the after I clean it. But I'll illustrate exploding the point cloud this way. So then so I will show cleaning in just a sec. We'll go through this. This is what cleaning looks like. Really interesting tool. You can actually move, and it'll hold on your to your last position. You can kind of just go through there, just wipe stuff out. Pretty easy. And you can multi-select a bunch of noise. You can pick all the noise at once and do it that way. So now there's another separation tool in here called segment by distance, and we're going to run that. And this kind of automatically knows, it always gives you a prompt that usually is right. I'll hit preview. It'll show me all my separate point clouds, right? It's separated them all. While we're looking at this, and I have another script that I wrote. This is not the one that I'm demoing, but we're going to randomize the colors so we can look at those again. This is what I'm doing here. Yep. So I've randomized the colors. I just hit the run tool. I wrote a little script that randomizes all the colors in of visible point clouds. But if we look here, for example, we'll see that it kept these segments together. One of the things I did in the cleaning process was I segmented out these chevrons and then separated these two lines because I want each one to be aligned. There's a couple other places like that, like this triangle here. Segmented here and here. It doesn't do this script that I wrote doesn't do polygons. Anyway, so let's go look at a cleaned up version. I'll turn this off. Look at a cleaned up version again. So I segmented it by distance, and now I'll have something that looks like this. And this is a cleaned up version without the noise. So now, I've written a script, right? I've got a script written for, and I'll talk about how I came to this conclusion. So I figured out how to, as I was exploring, I figured out how to separate out all these paint stripes, and I started seeing a relationship to power lines. I mean, doesn't this look a lot like power lines? Even with this this parabolic shape, and I started thinking about similar shapes and seeing this as more like power lines. And there's a power line tool, there's an electric line extraction tool, right? And it looks like this. And I read through it, and there's all these default scripts in here. So if you need a starting point, I'm going to talk about that in a minute. But you can copy this. You can I just copy this and just go, it looks similar to what I wanted, and hit new. And oh, I forgot to, forgot to copy it. Sorry, everyone. Stop. Here we go. I'll hit new, and yeah, so I can just copy it. This is for yours. If you have this program, this is yours to, you just go ahead and just start from there. And that's what I did. What I found out was that you had to click point by point by point, and that wasn't going to work. I need to draw a line on all of them. So I wrote my own script, and what I did was, and I'll talk about how it works. This one, okay. So you can see it looks very, very similar. And what I did was I gave it a variable. And you'll learn this if you know some JavaScript or you know some Python or something like that. I gave it a variable. I said all the clouds that are visible in the window. This is what I've done. And I said if this is an if statement in JavaScript. And what I did was I said if there are any visible clouds, run this code. And then I gave it a for loop. What a for loop does is again, you know, like an 8-hour session in JavaScript tutorial on YouTube, you'll learn this. I said for each item, for each cloud in here, I want you to run these commands. And on these commands, I want you to pick a random point on there. And I want you to pick a random point on there. And that's this right here. What I'm doing is I'm uncommenting it. So you can, I'll show the points where it picks. Picks a random point, and then what it'll do is it'll take each one of these clouds, and there's a tool in here, and I'll expose this after we run the script, is there's a tool in here called region free grow polyline. It'll pick a polyline, and it'll pick a point cloud, which each one of these is a separate point cloud, like this right here, separate point cloud. It'll try to grow a polyline, try to best fit a polyline, because previously there's a similar tool. It looks a lot like this. So I just select all these, and I can go to best line. It'll try to fit a line, but you know the hazard with this is it just fits straight lines. So that doesn't work. It does great for these center stripes. I mean, it does perfect, right? Does an awesome job, labels them and everything, but that's still not what we want. We want a curved line to follow this shape. So that's what this does. But again, this went through my litmus test. That's not exposed to the user in here. That's only exposed in the scripting library. And then I added some tools here that will set a name for each line, set the color, and then move it to its own separate folder. So without further ado, let's give it a run. So what it's doing is it's going through each line, each cloud, and it's analyzing each cloud. And what it's showing here is where the pick points were. So if I zoom in, it'll show a pick point for each one of those paint stripes. And then I'll go ahead and switch off the points, and I'll switch off the paint. And there we go. We have 3D polylines. Each one of these is a 3D polyline of that follows the curve. And so again, 3D. There we go. Yeah. So follows it dead on. You got all your center stripes. Previously, you'd be darting in and out of traffic to get those, but now you got them from an hour-long scan and about, you know, an hour and 3DR of, you know, setting up the project and, you know, cleaning things up and getting to this point. And now I've got, I mean, I'm not going to say it got everything. It certainly didn't. There's some missing areas here where the paint striping's weak, but it allows me to go then join these polylines up and more comprehensively follow the shape. So now that we have that, oh, another interesting tool. We can 3DR is cool because you know, if you have a CAD drawing open, you add the add-in, you can just hit send to, and it'll send it to your open CAD drawing. You just as you extract stuff in here. I call 3DR CAD's best friend, because you can go in here and just extract a bunch of stuff and then just shoot it over to CAD whenever you're done with it, and clear it out of this project, or save it, whatever works for you. So we'll go through some of the tools on how do I do this myself. And So the help file is here. So oh, and how I saved the script was I wrote a script and I hit this little star button and it puts it over here. So it just opens the tool. Now the hazard with this is when you click this button, it starts by running it immediately. So it already hits the play button. So you might have seen that on the colorization tool. So this is the scripting documentation. And then also really cool in here, there's a link here and a link here. This will take you to GitHub. And in GitHub, there's a bunch of sample scripts and tips and tricks on how to write a script and, just hints. Here, I mean, there's one for specifically to mesh a single tree. It's all exposed to you as a user. You can download this or copy it. Real easy to understand. It even gives you this project even gives you sample data. This NSD is point clouds. There's a point cloud of just like a kind of a this tree, this actual tree, and then you get this result here. So this is a really nice resource to have, and there's a link to it in the handout. Now we're going to go back, one more. There we go. Okay, so this is the scripting documentation. So there's a lot of things that you can read through here, but when you're using this, most of the tools that you'll be working with there's these namespaces that, and a namespace is kind of like tells you what the organization of it is. So it's like under these different, families. Like imagine like a big business where there's different business units, and each one of these is kind of a business unit with employees under it, or departments under it. And then if you think about it and then so each one of these will have classes associated with it, right? And anyway, so these are some namespaces. But 99% of your time in here will be spent in the S cloud. So these are kind of like the different departments. And each one of these classes you just think class is a thing I see in my window. So like a cloud, we'll go over here. We'll turn our clouds back on. Oh, I forgot to show something here. We'll show the road surface and real color. Take a look at how we did. Yeah, pretty good, huh? That's pretty dead on. So this cloud, we click on the cloud and we come over here to our tool. That's an S cloud. So it's in the, and then what, these are all methods. This is sort of cloud object. And these are all methods on this object. These are like tools. Think of these as tools or even like employees. Like I said, if we're going to go with this management analogy, this is a department, and these are all the employees in the department. They all have a different role. And so, for example, we're going to go look at what I use, region free grow polyline, S cloud, region free grow polyline. And there's an explainer here. It tells you exactly what to put in there and says, this is what I need. And so I needed a seed point, and I had to figure out how to randomly do that. And so I saw that, and I went and I said, there's got to be a way to do that. And there happens to be this tool called, where is it? It is the cloud iterator, right? So you can get a cloud iterator, and what that does is it'll go through the cloud point by point by point. And so it automatically picks a point that's on that point cloud instead of like, yeah, if you picked like a centroid or you picked something, it might not pick the same way every time, but you're guaranteed with this one that it's going to pick a point on that point cloud. So go to region free grow polyline here, and then you have to give it a sampling step. So these are 2 parameters. And then when it runs it, it returns the multi-line, and then you just have to add that to the document. We'll see what that looks like. So like I said, I got that cloud. I went through each cloud. This is a group of clouds. I went in this for loop, lets me examine each one and apply something to each one of those point clouds. And I did something to it. So again, going back up to the iterator point, you saw what those looked like. It just picked a point on the cloud and did something to it. And then it changed the color of that return multi-line and then added it to the document. right? And that's kind of it. You go through. So ran this job. So let's talk about the full life cycle of this. Again, we'll speak to the managers on the call. I went and ran this whole thing, and this is a post-process solution too. This is tied to a static base station, and there's ground control points out there. That was previously said. I'm not including that, but running this took us about an hour, and then processing it took a couple hours. Most of that, like I said, it's a big project. Most of that's in classification, and then running it through 3DR, maybe as long as an hour and 15 minutes total. And I've got all those paint stripes. Yeah, I've got all these paint stripes, ready to clean up and add to my CAD drawing. And that's kind of it. And I mean, I hope that's not anticlimactic, but with a little bit of smarts, with a little bit of investment time, a little bit of R&D time, and you can figure this out. Anybody in this call can figure this out. And again, speaking from the surveyor point of mind, and then being an surveying and engineering my whole career, surveyors and engineers, we solve problems. This is just another puzzle to put together. This is just like a boundary. This is just like, putting together a drainage plan. It's just figuring out the tools that you need and putting them together and figuring out the right way to communicate it. But that's it for the presentation. I'll turn it over to any questions.
Thank you so much, Kyle. That is awesome. I'm curious how much time that saved you. I mean, Cyclone 3DR already has a lot of automation built in, as you were showing us, but how much time would it have taken you to do that, to do the paint striping without the scripting?
So a good drafter, they could probably do this in a day, maybe 6 to 8 hours, I think. Somebody just going through and extracting it manually, maybe they'd be faster than me, but man, that's tedious. And if you have a good drafter, you want them making your final documents look really nice, right? You want them adding labels and making sure the sizes look good and making sure they're error free. You don't want them doing this like click, 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 click. It's kind of like a waste of time. If you can do it a much quicker way. So, like I said, probably for me, I bet I could do this in like 6 to 8 hours. Pull these all out manually. And I'm not saying there's not other tools out there too that could do something similar, but for me, this is the way that I figured out to make it work.
Well, and you mentioned most companies probably having someone on staff who has that scripting capability, who understands JavaScript, who has GIS experience in some way. But what about using something like ChatGPT to create the script? Is that possible? Is that something you've played with?
Yeah, and I actually checked this morning to see if it could help me. And if you want to use ChatGPT and for this, it doesn't have access to this library, right? It just doesn't have access to this. And I don't even think it knows what Cyclone 3DR is. But what you can use it to do is help you with logic. So if you enter in some generic, so like right here, you can enter in some generic logic and print these instead. And if something's breaking, like you have a logic error, it can help you find, it can help you clean up your syntax, modernize it. For example, this is an old habit. This should say let. And Chat GPT would catch something like this. It's a variable is that's the old way of doing it. And do let, right? And I've got it here and here and here. It's just old habit. So Chat GPT can be helpful, and it can also answer questions about like what is a for loop, or how do I set up a for loop, or how do I set up an object, or how do I write a function in modern JavaScript. It's helpful for stuff like that.
Okay, good to know. Well, what about for someone who maybe they don't have the right person on staff, but they're interested in learning how to do this? And they are starting from ground zero, right? How long would it take someone to be able to feel comfortable and confident doing this type of scripting?
Really, given the fact that you can start from practice scripts and there's a lot of guidance here. What I would recommend doing is, and I have a link in the handout, there's a programming course called Code by Mosh. The guy's super easy to understand. Um, you don't even have to learn in integrated development environment and all. There's a lot of extra stuff around programming. It's all right here. It's already built in for you. It does a lot of the work for you. So I would say take a day's worth of JavaScript so you can kind of get familiar with some of the keywords that I've put in the presentation. Make sure you're comfortable with those and understand what they do. Read some of the code, and maybe, like, my guess is, like, for some people maybe like 2 or 3 days, some people a week, maybe some people a little bit longer, but you should be able to write your own first script. And, like, even for somebody who's totally green, doesn't understand where this is coming from, what's happening, you just dive into one of those YouTube courses, get the basics of the language. Um, you know, a week, 2 weeks maybe. But for somebody who's experienced, like, just learning how to use the library, and you're going in a day. So,
And you taught yourself how to do this, right?
oh yeah, yeah. I just taught myself how to do it. It was just out of necessity. It's not. That's what we are. We're scrappy. I mean, the surveyors are scrappy. You see that there's a tool there, and you figure out how to use it. You don't let data volume be a barrier to you. You got to figure out how to use it. And um, a look behind the curtain. The reason I picked 3DR and the reason I learned it so well was when I was a LiDAR department manager, I needed one tool that did everything. And I worked for a civil engineering company at the time. And there's a lot of tools, a lot of LiDAR tools, especially terrestrial LiDAR tools that are tailored towards a plant environment. Well, topographic extraction is actually extra hard because none of these features in here that you see are manufactured. I mean, at best, this is painted by a shaky machine, driven by an indifferent operator. We've all seen a road being built, right? So this isn't perfect, and it introduces complexity to extraction. So this isn't pipes. This isn't, flanges, things that are manufactured that can be modeled. So I had to get really creative, and I went all in on this tool for other reasons, and I had to make it work for Topo. And once I figured it out, once I got over that hurdle, I just absolutely fell in love with this program because it's like it never says no to a workflow. Any workflow you have, the answer's probably in here.
And is it possible to even eliminate other pieces in your workflow? Like, is it conceivable that someone could write scripts to replace other pieces of software to just streamline that whole process?
Yeah, yeah, I think so. I think if you're using one tool for just like one specific thing, um, you go, oh well, it's got the best this. It's got the best. I love the ground extraction in this one tool, right? Well, this covers that. It's like pretty much anything you're going to touch, anything. And they recently introduced a piping tool, and I expect the tool is very fast. Right now, it's a little bit limited. You can only do the cylinders, but I expect as it just really got released this year, this tool. But I expect as the releases happen throughout the year that more will be added to this because it's very popular and it's really, really nice to use. And shameless pitch. Um, yeah, I hope I hope we have lots of Leica customers on here. And one of the things I'll say as a Leica customer in the past, your CCPs are worth every penny. And I say that as a customer. And this software is a great example. Within the past 6 months, they've added full mobile mapping support, trajectory lines, where I can go through a mobile mapping trajectory line and look at all my images, a piping tool. They've completely rewritten this scripting engine to make it much better and easier to use. They've added a bunch of different improvements, and that happens every release, like clockwork. You get something new and something great to help you out. So generally, the hottest fires get put out first. So if a lot of people are clamoring for it, that comes out. So if you've got a common workflow, odds are it's in the works. Somebody's trying to, someone's trying to put it in here, right? Does that answer the question?
Yes, it does. Thank you so much. We have a question, and I might need some clarification here, either from Jonathan or Brian, who's asking the question. But was this machine built specifically for 3DR? And I'm not sure if the question refers to the TRK. He's curious about the processing speeds on some of the tools. So if you could just clarify if you're referring to the TRK mobile mapping system or something else. Jonathan, I'm not sure if you have any insight there.
I mean, I can speak to both. Yeah, go ahead.
So Brian is asking about the computer itself, so your PC and then your general processing times.
This PC is just an HP ZBook. It does have an upgraded graphics card, but it's not a gaming computer. It has an Intel i9 processor. It has an Intel i9 processor, 64 gigabytes of RAM. We recommend having 2 SSDs, one for storing data and one for your operating system, so you have plenty of room. And then it has an RTX A4000. So an upgraded workbook, but a typical, a typical corporate laptop. And I processed this entire job on this laptop. For what you see here, to get to the original point cloud that we had and get it on the correct datum, after we pulled it off, well, not counting like loading times. Turn this back on here real quick. I'm not sure, we're having a little lag. For this amount of data, it was same day. So we went and collected it. We went and collected it around 10:30 in the morning, and then went and got something to eat. Set it up to process. Went and got something to eat. All the importing, and then by 3 or 4, we were in the finalization process. It was an instruction thing. I think as an experienced user, if you had an upgraded computer, I mean, this probably wouldn't take to get to this point. 3-4 hours to get to here, and then loading it in here, the import time with TRK data, it does take a little bit of time. It down samples it, and then if you want to import images, it takes a little bit longer. That's extra data, but not really anymore. Like this project, no under 15 minutes to get it in here as an LGS while it cranked through all those images and added the lines. And then you saw the processing. The only thing you didn't see was about 20 minutes of cleanup on those paint stripes.
And trust me, nobody wants to watch Kyle doing that.
No, we don't. So, is that comprehensive of enough of an answer? So theoretically, you could get to where I got in a day. You went and drove in the morning. It would be possible to get to this result in a day.
And that has huge impacts for a business. Like that level of efficiency is substantial.
It's fast. It's really, really fast. And it just helps you be, I mean, I think there's some, one of the questions that I hear a lot from people is like, is this oversimplifying things? And it's like, why wouldn't you want to oversimplify collection in the field? I mean, if we look again, we look at this road traffic. I'm gonna turn it on again. Wait for it to load. If we look at it, it's full of traffic. I need to, and I'm driving, and I'm driving highway speed here. I'm going 65 miles an hour. I need to pay attention. So I need this collection to go really, really smoothly and simply, and like do a lot of the thinking for me, which the Pegasus does. So simplification in a lot of places is really good. And also, it doesn't bring me any extra glory with my customers that I know that every intricate detail of how the IMU relates to the GPS unit. I just need the thing to collect the data in it to look good and to come in on my datum. What the customer's impressed with is how quick I can get them those lines we were talking about. That's what they want.
Once you write a script for a process that you're going to be doing again in the future, as you said, kind of that barometer for does it make sense to do a script, what happens to the script? How do you quickly and easily access it again for future projects?
Oh, you just store it in a folder. You store it in a local folder. You can help us out and put it on GitHub if you want. You can put this on. You can put it on a Dropbox. It's all this is a. We're gonna open this up. Open with command prompt. Now we'll open it with Visual Studio Code. All this is a text file. All this is some text. This is a text editor. Yeah, so all this is a text file. That's literally it. Really easy to understand. So actually, I think I clicked the wrong thing here. Show our script, yeah.
Can you add a shortcut into 3DR to make it easy to access for the future?
Oh yeah, definitely. Oh, it's already open. That's why. Whoops. I need to show you a different one, but this is basically just text. That .js, you can change it to .txt and it'll load up in here. To save it in 3DR itself is, like I said, you hit this star button and it'll pop up here. Right. Easy to access, easy to find. And you can use an external file. It's interesting. You can give it a path if you want to. You know the path. Mostly I just do this. I just have it saved on a local folder. Just grab what I want.
Okay, and then we do have, again, as Kyle mentioned, there's a handout that I would encourage all of you to download before you leave the session today. That has a number of resources, some YouTube links. I know someone specifically had a question about the JavaScript YouTube courses, and those are in that handout, so you can find that link there. I think that we have, at this point, we've addressed all the questions. Jonathan, are you seeing anything that I've missed?
I believe so. The only thing left would be there's a question about nearness to hydro wires affecting it, but we'll need a little more clarification before we can answer that.
If that's for
Okay.
the TRK, then it's just a time of flight LiDAR thing. So no. Then the answer is no. There's not going to be anything that affects it. So I mean, here's some high tension power lines right here, and you can see the data is the same on the entire project. Hopefully that might not be your question, but this is meant to go anywhere, go over any surface that you can drive on, and it's whatever kind of interference, they've already worked all that out.
Okay, excellent. Well, thank you, Kyle. The link to the recording of today's session will be sent out to everyone tomorrow, along with additional resources. So please be sure to watch for that email. For those of you who use GNSS in your survey work, I did want to let you know about a session coming up on March 14th that will show you how to get more from your RTK GNSS. So please do check out the link in the chat box. I just posted it there, and sign up to join us for that session. Our next session in the Reality Capture Education Series will be on April 25th with Jason Dixon. Please be sure to watch your email inbox and check puresurveying.com/insights for the link to register. As you exit the webinar today, please fill out the survey that should pop up on your screen. We appreciate your time and hope that you found this webinar to be a valuable experience. Thank you so much, everyone.
Thank you for sharing your day with me. I appreciate that, everyone. Thanks for looking at this.
Thank you. Bye-bye.